The lesson outcomes for this video are: I can use the distributive property, and I can combine like terms. So, on the first page here, we are going to talk about the distributive property. And there is a root word in the word distributive, and that is the word distribute. Well, if you think about what the word distribute means to hand out, right? If I was the teacher and I was handing out worksheets, I might say I'm distributing the worksheets to my students. So it's kind of like handing things out to a group. So let's look at this first example, 3 times the quantity x plus 4. By the way, that's what we say when we have parentheses like this. We say 3 times, there's multiplication between here, the quantity x plus 4. That tells you that that's in parentheses. Well, if I was going to distribute this 3 to everything in this factor here, it means I'm going to give the 3 to both terms in the parentheses. You probably have seen this before with an arrow, like so. So 3 needs to be multiplied, because that's the symbol in here. When there is no symbol, it's multiplication. So it needs to be multiplied by x, and then the 3 also needs to be distributed, or given to, the other term, which is 4. So we need to multiply the 3 times 4. So it'll look kind of like this, if I were to write it out like the long way. So 3 needs to be multiplied by x, and then we're going to keep that plus sign there. And then the 3 needs to be multiplied by the 4, right? So the 3 is multiplied by the x, that's right here, plus the 3 is then multiplied by the 4. Now, of course, we're going to simplify this, and many of you are not going to need this second step in the middle. When we simplify, we know that 3 times x is another way of saying 3x, and then plus, and then 3 times 4 is 12. So this is our simplified way of writing after we use the distributive property, 3x plus 12. Now be careful, because the number one mistake that people make is they distribute the 3 here, so they get 3x, and then they're not taking their time, and they just write plus 4. And again, it is not 4, it needs to be 12. Let's look at a couple of other examples. So 2 times the quantity x minus 7. Again, we're going to multiply the 2 here and here. So again, many of you won't need this middle step right here, so we might be able to jump straight to our final simplified solution, or simplified version of this expression. So 2 times x is 2x, and 2 times 7 is 14, and we're going to need to bring that minus sign down as well. So 2 times 7 is 14. So 2x minus 14. Now the next one looks a little different, but it is actually very much the same. We're going to still distribute the 4 to everything in the parentheses. We'll just kind of do that in kind of a backwards looking kind of way. So the 4 needs to be multiplied by the x, and the 4 needs to be multiplied by that 5. So 4 times x is 4x. Bring that minus sign down right here, and then 4 times 5 is 20. This next one, you have to be careful because of the double negative situation that occurs, and I'll show you that. So if we multiply our distributing situation right there, we're going to multiply there, and we're going to multiply here. So when we take negative 4 times x, negative 4 times x is negative 4x. And then, like I keep telling you in the previous examples, we're just going to bring that minus sign straight down. So I'm going to bring that right here. And then what happens is we multiply negative 4 times 1, which is negative 4. Now you'll notice you have a negative 4 now right here, right? A negative, when you're adding and subtracting, a negative makes a plus. So if we wanted to rewrite that, we could have negative 4x plus 4. All right, so the second type of problem we're going to work on in this lesson is combining like terms. And as you can see here in our first example, we have a whole bunch of terms. Now remember, terms are always separated by plus or minus. All right, our operations add and subtract. So there's a term 3x, we got plus, a term is 1, plus, another term is 2y, and so on. So there's 1, 2, 3, 4, 5, 6 terms here. We want to combine any terms that are like terms. Now, how do we know when terms are like terms? Well, they're like if they have the same variable part. And that's an important thing to remember. Like terms are when they have the same variable part. So this first term are two factors here. 3 is a factor and x is a factor. So we have two terms, 3 and x. The variable part of that is, of course, x. So if I've got a term with an x variable, what I need to do is look to see if I have another term with an x variable. And I do. It's right here. It's this 2x. But be careful, because notice I underline the 2x, but I also should underline the symbol that comes in front of it, because that goes along with the 2x. So what that means now is I have 3 x's, and then I need to subtract 2 x's. It's kind of like having 3 apples and taking away 2 apples. Well, that leaves us with 1 apple. So I'm going to write 1x when I combine those two terms. My next term in the sequence here is a positive 1. Notice there is no variable part, which makes it called a constant. I should write that down here. A constant has no variable part. And a variable, of course, makes something vary, which is why when it doesn't have a variable, it's constant. So 2 is a constant, -5 is a constant, etc. All right, so this is called a constant, and I'm going to again underline the symbol in front of it, the operation positive 1, and I'm going to look for another term that does not have a variable part, and that is over here, a positive 8. So positive 1 and positive 8, when combined, gives us positive 9. 1 plus 8. All right, we're going to look for more like terms. I notice I have a y variable right here. So I have a positive 2y, and I have another y variable here, so positive 5y. Positive 2y plus positive 5, or plus 5y is 7y. So we're going to write plus 7y. Sorry, I had the wrong ink color there. Plus 7y. At this point, we're not going to worry about writing our final simplified expression in a specific order. Just 1x plus 9 plus 7y is fine. Now the next example does pretty much the same thing, but you'll notice some x squareds. An x squared is a different variable part than x. So you remember up here x and y were different variable parts. X and x squared are also different variable parts. They need to be combined separately. So I'm going to start with this negative 2x, and I'm going to look for any other term with just an x portion, which right here, positive 9x, and there is no others. So integer work, which means adding negative and positive numbers, we need to be careful. So negative 2x plus 9x, well, negative 2 plus 9 is 7, right? So if you think about going from negative 2 and adding 9 to it, you get to 7. So 7x, and we can work on integer work if you need it. And then we've got a positive 2x squared, and we do in fact have another x squared variable part over here. So we have 2x squared, positive, and a 6x squared, that's positive. So together that makes 8x squared, and you just leave the x squared. You don't make it x to the 4th or anything like that, just leave it as x squared term. And lastly, we have yet another part. We have a 5y right here, and there is nothing to combine it with, so we just add 5y. Very important to notice this. We are not going to now combine this x term with this x squared term. They are not like terms. We stop here. This is it. That's as simplified as we can go. Okay. So the very last thing I'm going to do in this video is combine those two topics, the distributive property and combining like terms. So you'll notice we have 3w plus 2 times the quantity w minus 7. To simplify this, we're going to first need to distribute. So be careful. What we have is here's our parentheses, and in front of it is a positive 2. So we need to distribute that positive 2 to our w, and 2 are 7. When you do this, I'd like you to rewrite the 3W. So we're going to rewrite 3W plus, and now we've got 2 times W, so that's 2W. And bring down the minus sign right away. And then we've got 2 times 7, which is 14. So 3W plus 2W minus 14, you'll notice that you do have a set of like terms, and they are the 3W and the positive 2W. 3W's plus 2W's is 5W's, so 5W minus 14. And that is as simplified as possible.